Hello, can you guys hear me?
Yes, ma'am, we can.
Okay, all right, so let us get started. Welcome to Engineering Mathematics 2. So since today is the first lecture that we will be having, we will start by going over a brief introduction of what to expect in the course, and then we will actually then go into what it is we are supposed to do for today. So let me just introduce myself. Okay, you guys are all mechanical students, I believe. I am Mrs. Lutopu. I hope you can see my screen. It's sharing. That is how you write my name. And I will be teaching you guys Engineering Mathematics 2. So the prerequisite to this course, Engineering Mathematics 1, if you made it through that one, believe me, this one will not be a problem. So don't worry. If you study hard, pay attention, do the work, then we won't have any problems. Okay, so again, this is my name, Lutopu Kwa, and I will be your lecturer for this semester. So you can contact me on the WhatsApp group. I put a link there on Teams, so you can join the WhatsApp group, you can contact me there. Please, let's keep the group academics only, no photos, no funny memes or stuff like that. It's for academics only. So if you feel that you can't be in a group where you have to share funny things, then that group is definitely not for you. Okay, so you can contact me there on the WhatsApp group if you need something. I will try and help you as soon as I see the message. Otherwise, you can email me. My email is lkhoa@nust.na. I hope you guys can see my screen and what I'm writing. There's nobody saying anything.
Yes, ma'am, we can see.
Okay, so this is L, initials of my first name, and then kwa@nust.na. So also email me if you need something. I would really prefer if you use your official NUST email address. So please use so each and every single one of you has a NUST email address. It's not nice getting emails from Rihanna's #1fan@gmail.com. I don't know who that is. So you tell me I need help with this and I'm talking to Rihanna's #1fan. What? I can't help you with that. Okay, so please use your official NUST email address because your student number is there, your details are there. I will know how to help you. If I have to look up your paper, I have all your details and it doesn't take too long. Right, and my office number, can use 083-207-2788. You can also use 061-207-2788. Okay, so sometimes the 061 is not working, so the 081 is usually working, but either one is fine. You can contact me almost all the time when I'm in the office. So my timetable is still being finalized, so I will put it up on the door for my consultation hours. Those are not the only times that you may consult me. Those are just the times when I am definitely available. So if you are on campus, you come by and I'm in the office. If I'm not busy with something else, then for sure I will help you. Okay, but all this again is contained in the course outline, which I would like us to go through very quickly just now. So let me share that. After the class, I will also post the course outline here on Teams, and you can go through it at your own pace. So if I'm going through it a little bit fast, it's because I just want us to go over the basics, and then later on when you have more time, you can go through it at your own pace. Okay, let me see. Okay, this is the course outline. I hope you can see it. Let me know if you can see it, please.
We can see it, ma'am.
Okay. Right. So again, like I said, after the class, I will post it here on Teams, and then you can download it and read it at your own pace. The course coordinator is Mr. TK, whom you guys all love. So he's the one setting the papers. But again, like I said, if you manage to pass Math 1, there will be no problems. This one is usually a walk in the park. Okay, so here are basic information about the course. The programs, these are the people that are taking the course. I don't see you guys here, but you should be included as your mechanical. There's Bell, BPen, Gem, Geo, Tech Civil. Okay, but you guys are supposed to be registered here anyway. So we will meet 5 times a week, 1 hour for each session. The first one, Monday at 11:30. So we didn't meet yesterday because I didn't have the list, you guys, this name, so I couldn't add you to the teams. So that's why we didn't meet yesterday. And if you know other classmates who are supposed to be here but are not, you can tell them to contact me, and then I will add them to the group. So Mondays we meet at 11:30. Tuesday we meet at 2 o'clock, that's today. Wednesday we meet at 8:30, Thursday we meet at 11:30, and Friday we meet at 9:30. So those are the times. For now, classes will be online. Since winter is ending, I suspect soon we will go back to face-to-face classes. I think that will be better. So we are just waiting for management to give us the go-ahead. So as soon as that is cleared, hopefully we will start with face-to-face classes soon. Like I said, prerequisite Engineering Mathematics 1. This course is compulsory. It is not an elective course. We will have classes online for now via MS Teams. We will make use of the e-learning Moodle platform. If you are not enrolled yet, please do enroll. The enrollment key is the course code, which is ENM520S. Okay, everything is in capital letters. And then we have face-to-face sessions that will hopefully start soon. Okay, the course format, this you can read, how many contact hours we expect to have during the semester, and how many hours you should have for directed self-learning and self-directed learning. That's how much time you should spend revising and acquainting yourself with this course. So this is the lecturers. These are the lecturers in the course. There's me. There I am. My contact details again, that's my email address. Please remember to use your official NUST email address when sending it, just so that I know who I'm talking to, and it's always easier to help somebody when you know who you're talking to. That is my number. My office is in the Health and Applied Sciences building, so it's the big white building on Lower Campus. It's on the ground floor, room G, or office G49. So again, and hopefully by the end of the week, my timetable will be finalized, and I will have my consultation hours there. Again, those are not the only times you may see me. Those are just the times when I will definitely be available. So other times, if you come, I'm not in the office, but if it is a consultation hour, I will definitely be in the office. So the other lecturers, Mr. Kainandunge, Mr. Ndadi, and like I said, Mr. TK is the course coordinator. Okay. What else? Okay, some prescribed reading, engineering, mathematics. There's the Technicon Mathematics Book 2, and there's this one, Advanced Mathematics for Scientists and Engineering, Strom's Outline Series. This is first year university mathematics students, so a mathematics course rather. So most of these topics, you can find them in just about any first year mathematics textbook you can get in the library. So you don't necessarily have to go and buy these books. We will, like with engineering math, use the Technicon quite a bit, but you can use other books in the library that cover the same topic. So we have some learning outcomes. Like these you can also go through, that at the end of this course, hopefully we will like for you to have developed. So again, go through those later on after I post the course outline here. Then our first topic is going to be differentiation. So the first 4 weeks we are going to spend on differentiation. Today we'll look at the introduction. So not really an introduction, but more of a revision, because we did a lot of that in Engineering Mathematics 1, and that wasn't too long ago, so I don't expect any of this to be new to you guys, especially for the first 3 parts of it. So we should move relatively fast. Then we look at inverse trig functions. It was quite interesting to see that some of you were using these methods already in Engineering Mathematics 1, and we hadn't even covered it. So it's like we're going to move very fast because I know you guys know them. Otherwise, how did you use them in the test when you didn't do it in class? But anyway, we also looked at hyperbolic functions, inverse derivatives of hyperbolic functions, the inverse hyperbolic functions, parametric functions, and then some of the applications. So the parts that are newish is this part over here from 1.2 to 1.6. Maybe those are a little bit new, but these applications, we covered them in Math 1, so they shouldn't be too difficult, and we can go over them relatively quickly. Then week 5 to 6, we look at partial differentiation and some applications. So here we look at integration of functions with several variables. So far what we've been doing is differentiating y with respect to x, but sometimes you have a function z that's in terms of x and y, and we want to work out its derivative. So that is what we will look at under partial differentiation and the applications. And then integration. We'll start with the standard integrals, the substitution method, integration of hyperbolic functions, integrals of inverse trig functions. Again, I saw a lot of this in the tests of engineering math 1. So it's like we have super genius students. When we get to all of this, it won't even be a problem. So what I will do is I'll just show you your paper and say, but you solved this using this method in engineering math 1, how come you don't understand what I'm doing here? Right, then integration by parts, another one that I saw last semester in the test. So this shouldn't be very difficult for you guys. Then that should take us about 2 weeks, from week 7 to 9. After which we have test 1, so test 2 rather, sorry. So test 1 will cover everything in differentiation up to the applications of differentiation, and then partial differentiation, integration, that is what will be covered in test 2. And then test 3 is in matrices. So last semester, matrices was more of a topic that you did on your own. So here we just build on it. And if you went through InSTEM, we covered quite a bit with matrices. So here we're building it. It's not really going to be an introduction, but that is what test 3 will cover. And then the last part is differential equations. Quite an interesting section, this one, but here it's like it's only first order differential equations, which are not too difficult to do, and including parts of matrices. That is what will be covered in test 4. Okay, so these knowledge areas, you can go through them at your own time. Please make sure that you do. It is very important that you acquaint yourself with the course outline. Then dates to take note of. Please take note of these dates. Very important, even though they are subject to changes. Take note of them and plan as if they are not going to change. So first assessment is on the 17th, so that's exactly a month away from today. And I know the first test always seems like it's so far away, but before you know it, we've covered so much and you haven't been studying. And like I said, it's very likely that we're going back to face-to-face. So all those tactics some of you were using when we're having online tests, you will not be able to do them. So make sure you actually know the stuff, so you don't have to do this course again. So these are the test dates. Take note of them. Again, I will post this course outline on Teams just after this class, so you can download them and take note of them. So there are 4 assessments, and then there's a supplementary or second opportunity test. This supplementary second opportunity test replaces a test that you have missed, or if you haven't missed a test, it replaces your lowest test. Okay, so again here, information for you to go through. That just says in the event that we have online tests weigh less than face-to-face tests. So yeah, that will all be dealt with as each test approaches, but it's good information for you to know. So you do need at least 50% in order to pass the test as your final mark. Anything less than 50 is a fail, so you get 49, that is a fail. So please make sure that you do your best right from the beginning. You're working hard, you're working consistently, so that you finish this course and move on. Okay, so here late assignment or assessment submissions are not allowed. A lot of you, when we say the test closes at 2 p.m., I'm getting emails 2:15, 30 minutes later, people are sending me emails. Please make sure you upload things on time, submit things on time. And then general information about the fees and student services that are available at NUST for free, I believe. Like student counseling, you feel you're not coping. And I know with the pandemic, it's a little bit difficult for people to cope, lots of things happening, whether it's academic or at home. There are services available for you guys. So they're free, take advantage of them. Then you can get help. I think Mr. TK will upload one that is signed by the HOD on e-learning, but the one I upload, the one he gave me here, it's not signed by the HOD, but I don't think very much will change when the HOD signs it. So this is an acknowledgement by the students. I would like you guys to fill this in, your name, your student number, and then you can scan and email it to me. So remember, use your official NUST email address. And that is it. So before we start with what it is we were supposed to do today, do we have any questions regarding the course, what I mentioned in the course outline, anything to clarify there? Okay. So I hope that means you guys are all fine, and then we can get started with the revision of differentiation. Start with differentiation. Okay, so if you remember with differentiation, what we are doing is working out the gradient of the curve. So we are trying to find what is the gradient of a curve. And the gradient is just the rate of change, delta y over delta x, because that's always something we're interested in, regardless of what your curve represents. You want to find out how fast is the price of a certain commodity going up, or how fast is it going down? Is it experiencing any change? You want to see, is something changing? And when you're working out how fast something is changing, that is the gradient. And the way we work out the gradient of a function is by differentiation. So there are several ways that we represent the derivative. We have y prime, that is the derivative. Sometimes you write it as dy dx. They mean the same thing. And the actual definition, or when we say find the derivative using the definition, what we do is we work out the limit as h goes to 0 of f of x plus h minus f of x divided by h. So all these are saying exactly the same thing. They're working out the gradient of a curve. They're just different ways of writing them. So obviously this is much shorter, so we prefer a shorthand way of writing it. This is the derivative using the definition. So with differentiation, there are some rules that we learned about when we're differentiating, and I'm sure you recall a table of derivatives that you may have used for your standard derivatives. I hope you still have that table, and then we'll just make use of it. So this is revision exercise 1.1.1 in your Technicon book. Look at question 1. We have y is equal to 2 over x plus 3 over x squared plus 2 multiplied by the square root of x cubed. Now with this question, what we are told to do is to work out the first derivative, or y prime. So this is pretty standard. 2 over x, remember 2 over x, you can look at it as 2 times x to the power of minus 1. And if you remember from your table, when it's x to the power of a constant, the constant comes down and then the exponent at the top decreases by 2. So here, what you could do is you can rewrite it as 2 times x to the power of minus 1 plus 3 times x to the power of minus 2 plus 2 times x to the power of 3 over 2. So remember, the square root means to the power of half. So this x is raised to the power of 3 and then to the power of half. So the laws of exponents, like we did last semester, if you have a base raised to an exponent and then to another exponent, what you do is you multiply the two exponents. So you have 3 and then half from the square root. 3 times a half is 3 over 2. So again, like I said, this is a standard integral. You have your base x that has a constant. So constant means there's no x up here. It's just a number. What happens is the exponent will come down. If there's a number like there is over here, there's a 2. When the exponent comes down, it'll multiply whatever number you have there. And then at the top, the exponent will decrease by 1. So what we will have is our derivative, say y prime. This is 2 times minus 1 and then x to the power of minus 2. So we can see my minus 1 came down. It's going to multiply by the 2 that was already there. At the top, say minus 1, you get minus 2. Then we do the same thing for the second one. So here we differentiate each part and add them together. So that was one of the rules of differentiation. If you want to work out the derivative of a sum, just differentiate each of the individual parts of the sum and then add the derivatives together. So here we do the same thing. 3 times minus 2, x to the power of minus 3, and then 2 times 3 over 2, x to the power of a half. Then we always want to leave our answer in its simplest form. So we have y prime, this is negative 2 over x squared. So in its simplest form, we like positive exponents. So that's why I've written it like that as a fraction. And then minus 6 over x to the power of 3 plus 3 times the square root of x. So x to the power of half over here is the square root of x. So this is the derivative of this function that we have over here. So this was a sum. I work out the derivative of each of them and then I add them together. If there were any like terms, I would combine them, but here I don't have any like terms, so this is my final answer. Okay, let's do the next one, number 3. So I don't want to do all the questions in all the exercises. What I would want you to do is to do them at home because it's good to practice. The way this course works is you do definitely need to practice. So make sure that you are practicing. So we have y is equal to 1 over the square root of x cubed plus the square root of 2x minus 1. So this one, we can do it in a similar manner to the way that we did the previous one, where you rewrite this as x to the power of something. And then this one over here, we use the chain rule. Hope you remember what the chain rule is. You differentiate the outside and then multiply that by the derivative of the inside. So it's sometimes called the outside-inside rule. Yeah, so y, this one I can just write as x to the power of negative 3 over 2. And then here I have 2x minus 1 to the power of a half. So here we do the same thing we did there. Now we're working out y prime. So notice I didn't just write equal to. I need to distinguish. This one was y. Now the derivative has started. So I write y prime. This is equal to the negative 3 over 2 comes down. The x stays as it is. At the top, we subtract 1. Negative 3 over 2 minus 1 is negative 5 over 2. And then for the second one, using the chain rule, the half will come down. At the top, it decreases by 1. The inside stays the same. That's the outside, when you differentiate the outside. And then you multiply that by the derivative of the inside. So on the inside, you have 2x plus 1. You differentiate 2x minus 1. You differentiate that, you get 2. So here, what I will have is my half comes down. My inside stays the same. The exponent has decreased by 1, and then I multiply by the derivative of the inside, which is equal to 2. Then we've differentiated this. The only thing left is to write it in a way that looks nice and neat. So doing that, we have y prime. This is equal to negative 3 over 2, the square root of x to the power of 5. Okay, try to negative 3 over 2 times the square root of x to the power of 5. And then we have plus 1 over the square root of 2x minus 1. That is our derivative. Then number 5, we have y is equal to x squared minus 1 over the square root of 2x plus 1. Whenever possible, what you should do is try and rewrite it like we did with the first two, where it's just x to the power of something, or in a simpler way, but sometimes it is not possible like we have in this case. So here we have a quotient, so what we need to do is make use of the quotient rule. So recall that the quotient rule, if you have y is equal to u over v. So here u is a function of x. So the one on top is my u, and v is what you have in the denominator, which is also a function of x. So we say that y prime, this is equal to v u prime minus u v prime divided by v squared. So you write down the denominator as it is, multiply that by the derivative of the numerator, and then you subtract the numerator as it is, and then you multiply it by the derivative of the denominator, and all this is divided by the denominator squared. So again, this is a rule that we learned last semester. Make sure everything we learned back there, you bring it with you, so you don't come to this class blank. Everything we learned there is for you to build on it here. So now making use of this quotient rule, we say that y prime, this is the denominator as it is. So you can see my denominator is the square root of 2x plus 1. So I write it like that, 2x plus 1. And then I multiply that by the derivative of the numerator. So my numerator is 2x squared minus 1. The derivative of 2x squared minus 1 is 2x. Then I subtract, u is the numerator as it is, so it's x squared minus 1. Here brackets are important because this is not just a single term, and there's this minus over here. So it's the numerator as it is, then I multiply that by the derivative of the denominator. So the derivative of the denominator, this is 1 over the square root of 2x plus 1. Okay, so that is the derivative of the denominator. So we've worked out a question like this where we have to work out the derivative using the chain rule, so you can work it out later on your own and see how did I get this. And then this is all divided by the denominator squared. So we have the denominator here, which is the square root of 2x plus 1, and then you square it. So the square root of 2x plus 1, and then you square it. From there, it's just a matter of simplifying what you have, leaving it in its simplest form. So this is 2x square root of 2x plus 1. And then we have this one, minus x squared minus 1 over the square root of 2x plus 1. And then in our denominator, we have 2x plus 1. So you can still simplify it a little bit, maybe separate the fractions. You can see these two have the same base, so you'll end up with the square root in the denominator, and then here you'll have it to the power of 3 over 2. So you can simplify that a little better by separating the fractions. So that is also something that you can do on your own. Okay, my tab is freezing. Okay, number 6, we have y is equal to the square root of x, e to the power of the square root of x. Here we have a product. So remember, we have such a thing as the product rule that we can use. So the product rule, let me use a different color here. So the product rule says if your y can be written as u times v, where u is a function of x and v is a function of x. So you have two functions of x that are multiplying together. The way we work out the derivative is not just differentiate both of them and then multiply. The formula for y prime is u v prime plus u prime v. So the first one as it is multiplied by the derivative of the second one, then the derivative of the second one multiplied by the derivative of the first one multiplied by the second one as it is. So again, something that we did and covered quite extensively last semester. So I expect you to know that and just apply it. So here we have to use the product rule, and then when we're differentiating this one, we will have to use the outside-inside rule. The other name just left my mind, but that's what we're using. Okay, so we have y, the chain rule. Yeah, that's what I wanted to say. So this is the square root of x multiplied by e to the power of the square root of x. So this is our first function, and then that one is our second function. So remember how the product rule works. We say that y prime is the first one as it is. So I write this. Just note that here I can always switch and say this is u prime v plus u v prime, because I'm adding them. The way that I write them doesn't matter. So I can say that this is u prime v plus u v prime. Okay, so it doesn't matter which way you do it in, because you're adding. With the product rule, with the quotient rule, the order that you do it in is important. It must be v u prime minus u v prime. You cannot do it in the other way around. The product rule, it's fine. The quotient rule, you must stick to the formula. So here I say the first one as it is, and then I multiply by the derivative of the second one. So when I'm differentiating the second one, this is e to the power of something. We know that e to the power of something, it remains as it is, and then we multiply by the derivative of that something. So this is e to the power of the square root of x, and then we multiply by the derivative of the square root of x. This is 1 over 2 square root of x. So this is our u, the way it is, and this is the derivative of the second term. And then we add the derivative of the first one, which is 1 over 2 square root of x, and then we multiply that by the second term as it is, or the second function as it is. And then as always, we try and simplify, see if there's anything that can cancel. With the first term, this square root of x and that square root of x will cancel. So what I have is a half e to the power of square root of x, and then with the second one there's nothing that can cancel, so I just have e to the power of square root of x divided by 2 square root of x, and that is my answer in its simplest form. So we cannot combine. You can factorize e square root of x out, but I don't know if that makes it look any better. Even half e to the power of square root of x, but I don't know if it's making it look that much better. But this answer over here is acceptable. Okay, so number 7, I want you guys to take like 2 minutes and try to differentiate number 7, and then we will go over it together. So please, when I give you something to do in class, I know it's online and I cannot supervise you, but it is important that you do it by yourself. You know where the answer comes from, so that in the test you will be able to do it. So take the next 2 minutes and try and do that one. Does anybody have an answer that they would like to share as the answer that they got?
Miss.
Yeah, go ahead, Johannes. You're a little bit soft. I don't know if it's my sound here.
I know, Miss. I don't understand how you get the previous answer.
Which part?
Number 6.
Yeah, number 6 is up here. So I'm saying, which part of number 6 are you talking about?
Yeah, from the first prime there.
Here?
I can't see your answer.
You
Oh yeah,
can't
now
see?
I can see it. Yeah, from there.
Yeah. What about this?
Now I can see it.
Okay.
Yeah.
Are you fine?
No, I don't understand. Can you please just quickly repeat the thing that you did, or
What
for
I
it to
say?
bring for it to, yeah.
What I say is, here you need to make use of the product rule. So again, the product rule is something that we did last semester. So if you don't remember, you need to go and find your notes on the product rule and revise some of those questions that you did. But the product rule looks like this. This is the
I
product.
understand the product.
Yeah. And what's the
Yeah,
problem?
I was trying it here, but I did not get it. I just don't. Just confusing here. Why did you put these two product in the brackets?
You mean the brackets are what is confusing you?
Yeah.
Well, you don't need the brackets because all three terms are multiplying. Putting the brackets there doesn't change anything.
Okay.
Okay, so
But
for numbers, yeah, go ahead.
uh, but 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 Miss,
Yeah,
uh, which one did you differentiate first? Was it the square root of x or the e to the power of the square root of x?
here the square root of x is still here, so obviously I didn't differentiate it. And then this one over here, it becomes this one, so it's the one that I differentiated. So the first one, I didn't change anything. The second one, I differentiated it. And then square root of x, I differentiated it. And then the second one, I haven't changed anything.
Okay. But if you differentiated the square root of x now at the first, where did this also the square root of x? Where did this square root of x came from?
Which square root of x? This first square root of x,
Yeah, the one out of the bracket.
it's from here. It's this one. I didn't differentiate it.
Okay. Okay, ma'am.
Right. So number 7, somebody who has the answer, please. Johannes, are you saying something? I can't hear you. Zachariah, do you have the answer?
I'm saying
Yeah, go ahead, whoever is speaking.
I am saying if you square you will have
You're very faint. You can barely make out what you're saying. So what I want you to just tell me is what the final answer is. What is y prime equal to? What did you get as your final simplified answer? Zakaria? Okay, does anybody have the answer? Like I said, you guys do need to participate and try the questions. So it's not just you watching passively as I do the things. You will not learn anything. Okay, so we'll stop here for today, and I will see you guys tomorrow.